So we've talked about the importance of testing the whole model and its significance by looking at the F statistic and specifically the p-value. But what about R squared? In the case of multiple linear regression, R squared is called the coefficient of multiple determination, not just the coefficient of determination. And generally, the higher the R squared, the better the model you have fits the data set that you've given the model that you're analyzing with the LM function. Remember, R squared is between 0 and 1, and the higher it gets, the better the model fits the data. That's a general principle. So what R squared specifically is looking at is the variation in the data that explains the model. It's a measure of the variation of the data in the data set that explains the model over the total variation in the whole data set. So the higher the number, the closer it gets to 1, the more the data set fits the model. So R squared is an important number to watch. Now, adjusted R squared turns out to be a better number to watch because what happens in multiple linear regression is anytime you add a new component to the model, something new in the model, and we'll show you that as we go through this exercise, multiple R squared is going to go up. But adjusted R squared is adjusting for the idea that you're always adding something new to the model, and R squared always is going to go up no matter what you add to the model. Adjusted R squared is better to look at to see it approaching 1, getting bigger and bigger, so that the model is getting better based on the data set. We're going to look at adjusted R squared as we build the model for attendance in Major League Baseball. Okay, so this first run here was a fairly simple model. Attendance is modeled by the home team. That's what we did first. And we looked at the output of the LM function. The output gives us the model itself. We get a sense of the residuals, and we want to check broadly, check for normalcy of the data, how normal the data is. The reference category within the model is determined by the intercept here. And then we also have dummy levels, dummy categories within the model that are relative to the reference. The final thing to talk about here in terms of the output, besides the adjusted R squared, which we'll always look at, and the p-value here for the significance of the model, are these asterisks here for each of the components in the categorical variable that we're looking at, in this case home. It's a statistical test between any given category in our model versus the reference category. So we're testing, is Detroit different than Anaheim? And when we do that test, we see 3 asterisks here, and that's going to give us a p-value. 3 asterisks means the p-value is between 0 and 0.001. 2 asterisks means it's between 0.001 and 0.01. 1 asterisk is only between 0.01 and 0.05. 1 dot is between 0.05 and 0.1. And if there's nothing included there, that means the p-value is between 0.1 and 1 itself. So what we can conclude here is that the estimate of change of the Mets home attendance versus the Anaheim home attendance, the estimates are fairly close. So the New York estimate, the New York attendance is not different than the reference category attendance, the Anaheim attendance. So this means something, but remember, all 31 categories are included in our model. In our first model, they're all included. All 31 categories of the home variable are part of the attendance model that we built with this LM function. So let's continue on building our model. We left off right here with the very simple model that attendance is modeled by the home team. Now let's add the idea that attendance is modeled by the home team and the visitor team. And this might make sense in that if the Yankees or the Dodgers are visiting another team, fans in that other home team area might want to go see the popular team. So maybe the visiting team has an impact on attendance, not just the home team having this determined impact on attendance. So that's what this new model is going to be. That attendance is modeled by the home team and the visiting team. So let's run that model. Let's run it. Okay, and now we'll do another summary. The attendance model is different now. We'll do a summary of the new attendance model. Let's look at that. Okay, here's where we ran the new model. The summary gives us the new model. Attendance is modeled by the home team and the visiting team. Looking at the residuals quickly, the median is close to 0. The first quartile and third quartile are about the same on different sides. And the minimum and the maximum are similar as well. So this looks like a fairly normal residual data set, and that's what you look for in these multiple linear regressions. The estimate, again, is here. It's changed a little. As we scroll down, we're going to get a new set of categorical variables. That estimate here includes an estimate for both Anaheim as the home team and then Anaheim as the visiting team. That sort of combination is what's being represented by this new intercept estimate. The new reference category includes Anaheim as a home team and Anaheim as a visiting team, kind of mishmashed together. And now we can look at the visiting data. How different are each of these categories relative to the intercept? Remember, the intercept is the starting point, and then we have estimate adjustments based on the home team and then based on the visiting team. So if we want to model attendance, we start with this number, 35814.3. We look at who the home team is, and if it's the Yankees, we're going to add this estimate if they're the Yankees at home. But if the Red Sox are visiting, we're going to add even more, because the Red Sox as a visiting team add more data to the original reference category estimate. So we can again see the significant difference of each of these rows relative to the reference category, and that's what's represented by these asterisks here. The one thing we always want to check is the F statistic. The p-value is still extremely small. This model does show that it's likely that the home team and the visiting team both impact attendance, given our data set. In other words, the model looks good when we have a low p-value on our F statistic. The adjusted R-squared value went up. The previous adjusted R-squared value was 0.4247. So this model is a better explanation of attendance. This model is a better model of attendance. We'll keep adding more components to the model, and that's what multiple linear regression is about, looking at multiple variables in our model that help determine our outcome or dependent variable, which is attendance. We want to model attendance by looking at the home team, visiting team, and now we'll add some other components.